Hello everyone, I'm Mike from the Masters of the Code, and in today's video I will be talking about that automatic scripts for generating your custom ROMs that I've already showed you in my previous video. Today we will be talking about customizing it further, so you will be able to use it on any Galaxy S series device and also other Android devices. Also remember to subscribe my channel, that way you won't miss my future videos. Also check links below that video. I will give you links for devices I use as always, and for more details check my previous video. So let's start it. What we will need to proceed with that tutorial: rooted Galaxy S series device. Best possible option is to use Magisk. Of course, BusyBox installed by Magisk module or any other way. Debian change root I've already talked about in my previous video. And for a brief idea how to use scripts for generating updates, see my previous video also. And what we will get after that tutorial, after configuration, you will get automatic way to generate your own firmware version based on stock Samsung firmware for Samsung Galaxy devices or any other firmware for other devices. Also pay attention, I will be shooting that video on DeX for Samsung also, because it's more comfortable for me than using just my phone. You can also connect through SSH using, for example, Sshdroid or ADB or any other way. Okay, so first let's go to Termux, switch to root, and because I'm using DeX, I don't have those scripts at my desktop as in regular phone mode. I will use just the script for mode, the change root environment here, and also I will switch to the change root environment now, and I will just use my local SD card here. So we will switch to the MNT SD card, and we will create some temp01 folder here. I should use make dir command for that, and now I can enter that directory. And also I will show you that on my external SD card, inside the tools folder ROM vendor ROM, I have two stock ROMs, and we will get the latest one. So it's CSB9, and what we will do, we will unpack it using 7-zip. So we will use 7-zip with MMT option, so it will use just more than one core of the CPU if I have available, and we will extract it here. So it's just X. Okay, it's unpacked. I'm using internal SD card because it's faster, but I should check that I have free space. Actually, I have only 5 gigs, so in some part I will probably have to use also my micro SD card at some level. And what I've done is the same part, just like we do for Odin update. So I've extracted firmware parts. It's AP BL4 bootloader. The AP part has inside the system, vendor, user data, and other partitions. BL has all files connected to bootloader. CP has the radio, the modem firmware. CSC responsible for CSC partition, and same for home CSC. And also, as you can see, those files have MD5 at the end. Those files are just regular tar archives, but at the end have added some MD5 hashes. I will show you later how I check it in my scripts, that the hash and the MD5 sum of those files matches, so you are sure you have correct firmware and it's downloaded correctly. Also, we can now run test. Probably it won't autocomplete if we have MD5 files that way, but we can do it like that and then use tar with test option, and we can compare it to the second file. Actually, autocomplete works with tar also. We can compare it. So as you can see, the first file have that speed file, so it's the partition layout inside. So the first file should be used if you want get your phone to the factory state, and the second one, the home CSC, is for using when you don't want to reset your phone to factory state. So let's get back to those files. So you can also see what is inside those files with test option from tar, and you can see that in application part we have boot, recovery system, vendor and user data files, and those files are also compressed with a zip4. So if you want to unpack it easily on the fly, you can use outputs to standard out option. It's uppercase O for tar and XF options also, and pipe by LZ4 cat and redirect it to the boot image file. And also you have to state that you want only boot image file here to the tar. Boot image LZ4. Yeah. And now you can see that we have that file extracted. Okay, so we can also, for example, do it for system image and vendor image. I will show you the vendor image, for example. So we will put it in the vendor.image file. As you can see, it's unpacked. I will remove the boot file, and that file is unpacked, but it's in sparse Android image file, and it means you can't just mode it and see what's inside, because it's not X4 file system here, and you need to use as image to image, so sparse image to regular image converter. You have already have it in the change root environment, so you can just type as image to image vendor here and e-vendor image, for example. So it will unpack it, and you will get the e-vendor image file, which could be mounted actually. Okay, and of course you can see that this second file is bigger, so that is why Samsung uses those sparse files, because firmware takes less space that way. We will remove that sparse image also, and we can just use mount with option loop, and we should probably create some MNT temp01, for example, here. So we have some directory where we can mount it, and loop option will try to configure loopback device for us in the background, and then we'll try to mount the X4 file system. So we can put e-vendor.img file here and destination. That way failed, but we can check for loop devices, and we can see that we have, for example, loop 7 device. We can also list all devices, and so we can see that loop 200 is used by our change root, but we have that loop 7 device available, and mount option doesn't work here because in Linux the standard folder for loop devices is as here /dev/loop device name, and in Android we have that block subdirectory. But we can of course use a low setup and use our loop 7 device and attach vendor image to that device, and now use mount to just mount that loop 7 device to the mnt temp directory, and it worked, like you can see. And inside we have mounted the vendor image from Samsung ROM. You can also make your own devices with mknote command, like I created in the mount script for change root environment. So that way probably mount command will also work so without using that low setup command. And you can see what's inside that zip. And for now maybe it's not that important to look inside. It will be more important in the second part when we will talk about preparing script for patching your ROMs. And now it's not that important, but I wanted to show you how it works. Okay, so we will unmount it, and we can also use detach that loop back device, and also you can see that the setup with switch doesn't see that loop 7 device in block directory, which is connected to that, like I showed you, that Android has it in different folder than Linux. So we will remove that vendor file, and I will also show you that despite some images, and those files are usually ended with img, like here at the end. So in most cases those are the sparse files. It's not always the case because for boot it works differently, but for the other stuff it's always a sparse image here. And for the other files, for example for modem part, you can see it's binary. Those files are binary files, and when you will just unpack it with LZ4, with tar first and then with LZ4, you will get just the file that should be uploaded to your device. So let's also check the bootloader part. There you have only binary files also, and the last part is that CSC part. And actually we should look at home CSC because it won't alter your device like the previous one. That is especially true for Odin. And here you also have some sparse images. So what you can do is trying to mount those files and look inside it, because for example cache image here, hidden image here, those files are not used. Actually Samsung just reserved those files for future use, but you don't need those files during flashing the ROM. So when you will just look inside those files, you will see that not all of them are crucial and not all of them should be flashed. And also you should read about your device at some forums, for example, because you can gather data about which files are exactly needed and need to be flashed. And when you have that, we can move to the script I've showed you in the previous video. So I have that script at my micro SD card tools folder, or also called masters. It's in ROM scripts, and we have the parent script, so script for doing the whole job here, but you can see that the first script that is triggered is prepare-zip.sh here from S9 prep firmware directory. So we should look at that script and we can just see that we have some checktar MD5 function here, and that is the function that is used for comparing the MD5 hash generated after creating those files by Samsung or the other vendor with the files that we have downloaded. So you can just see the code, and what it's doing is just retrieving that MD5 line length, which is also defined here from the end of those files. And then we are generating MD5 sum, but without that MD5 sum in file, and then we are comparing it. So for all those parts like AP and bootloader and the modem part and CSC part inside that whole big zip file downloaded from Samsung or other vendor, of course, we are comparing it. And you should also remember that not all vendors do it that way, and possibly Samsung wouldn't done it in the very old firmwares. So in that case, you can skip that part, or you should check how it had been done before and prepare some other function for that. But for recent Galaxy S series devices, it will be like that. So S8, S7, S6 is the same mechanism here. So as you can see below, the first thing what is done here is comparing that MD5, and also you can see that we have the whole script is separated to some parts. It's MD5 part here. You can put 0 or 1 here. So if you will put 1 here, it will be checked, and if you will put 0 here, it won't be checked. So by default it's not been checked. It's faster, but it's not been checked. You should remember it. The second part is extracting. It's mandatory because you have to extract those files inside. The third phase is a phase responsible for converting those sparse images files, and the bundle phase is responsible for building the whole zip file at the end. Okay, and we have that part I've already talked about in my previous video, the flash dash part, and here we have matchings between those files inside the firmware. So as you can see once again, we are taking files from here, for example boot image, system image, and we are defining where it should be put, so for which partition. And this is the crucial part. You can see all partitions. I've already showed you that in the previous video also, but I will show it once again. In that path, as you can see, you have all partitions by name, and you can just think about which partition should go where. Also, you can try to read about it if you are not sure. The crucial partition, like I said in the previous video, is the bootloader BOTA 0 partition, and less crucial may be BOTA 1 partition for the fingerprint reader part of the bootloader, and the remaining partitions are also important, but not that much as bootloader partition, because if you will put wrong file here, you will break your device, and if you will have that bootloader partition flashed correctly, you will always be able to go to the download mode, and you will be able to use Odin to get back to the working firmware, or you will be able to flash just the recovery partition, reflash it if it's also broken. So you will, for example, get the Tmun recovery working, and then you will be able to just test it again. So it's crucial to get it right. And as you can see, this set of partitions, that is the minimal working set. We don't need to put, like I said, the cache or any other partitions for Samsung ROMs. And you should also check, because in the previous devices, not all of those partitions are present on your device. So in that case, you should just remove it from here or rename it to the correct name, because the names also could vary somehow in the previous devices. And if you like it to use on the other devices, you should also take it into the consideration to just adjust those names. And also I will tell you about the second script later inside the zip file, the template script, which will be triggered under Tmun recovery, and you will have to correct the path to the dev folder there also. Briefly, I've talked about it in the previous video also, but now I will be cover that in some more details also. So as you can see, we have those 4 files from the Samsung firmware here, and we are just filtering by the beginning of the name, and then after the MD5 check phase, we are just extracting it to some temporary directory, and then in the loop we are just extracting correct parts, because the param variable here, as you can see, is taken from the flash part variable, and the flash part variable has all the matchings, and the separator here for the for loop in bash, it's pipe here, and then it's decomposed by colon, as you can see. So we have P1 and P2. The P1 is the part of the firmware like BL, AP, etc. And P2 is the name of the part of the firmware. We are not getting the third part because it's not needed here. It will be needed in that script inside the zip file using to flash that. I will show you that later also. And in the loop, as you can see here, we are just extracting those files. Of course, we are also checking exit codes here, and when we have when we using some commands using pipe, we are using that special array in bash pipe status, and we can just put the index here, so it's the number of the command using with pipe, and we can check that every of those commands return 0 status code. So it's a great approach for checking the commands in pipe configuration. And also we have here the failsafe, and why? Because all of those files should have the LZ4 format, okay, but it's not always true. Sometimes those files will be just in the regular format also. So as you can see here, it just won't work, and in that case we try to just enter it without LZ4, and if it works, we will move on further. And next, after unpacking, we have the phase responsible for converting those sparse image files. As you can see, we are converting not all of those files, but only the hidden partition, ODM, system, and vendor, not the any other file. And the last part here is responsible for just packing those files to the zip archive that we are able to flash under TeamWin recovery. So for that part, we can go to template directory, and inside the metainf directory com Google Android update binary script. Inside that script, like I said you briefly in the previous video, we have that part responsible for flashing those files on the device itself. It's a rather simple script. What is important, the destination base flash dest base path, because it should point to the correct path on your device. So you should check if it's correct and correct it if not. And the first part is the same like in the previous script, but that time we will also use the third part, so the partition when the files should go. And inside that script, what we are doing, we are first unmounting under recovery the system, vendor, ODM, hidden and cache partitions, because those partitions are in ext4 format, and we shouldn't flash those partitions when those partitions would be mounted under TeamWin recovery. So we should unmount it, and if it would fail here, it should just exit the whole process, because it's not correct and we can't be sure of the outcome. Okay, but if we have it unmounted correctly, so we can move forward to the next part. We are extracting those partitions, those files here, separated by pipe, as you can see here, and we are just using UI-print function. Its function to print something under TeamWin recovery. You can review it in the upper part of that script, and we are using also the unzip -flash function, and we are putting some variables like part of the firmware and also destination to put that file. Also here we are printing it if it failed. So if it failed, we will print some message also. And then at the end we are mounting cache partition, removing all files under the cache partition, and also we are clearing Dalvik cache, like I said in the previous video. And we are also syncing everything to the memory, so we are sure that we can reboot our device after that. So when we have installation complete message, we can just after that reboot our device. I will also show you interesting part here, but it's just simple. The UI print function, like I said before, it has to write something in a proc self, and the file is actually kept in that variable here, and that variable is pushed by tmun recovery. Actually is the second parameter, while the whole script is executed under tmun recovery. As you can see also as third parameter, it's zip file name itself. So that's why we have used UI print function, because if we would use just echo command, it wouldn't print it to the right window under tmun recovery. And also we have unzip flash, and that's the main function responsible for putting our firmware parts to the device partition itself. So how it works? We have some wipe variable here, but default value is false, so we don't need to wipe, and the false is used for partitions in ext4 format, for example. So we don't need to wipe those partitions during flashing. And for the other partitions, we should wipe it before. As you can see below, if we have some boot image, because that boot image has IMG extension, but it's not ext4 format. Also, if we have some bin extensions to those firmware parts, then we will use wipe. We will just use cut here to the standard output from dev0 to just fill out the rest of the space. So when we will unzip that firmware part, for example, that bootloader part, some cm.bin, for example, that's the fingerprint reader part. So we will just add zeros after it to fill out the whole partition. And that's that way we will be sure that we won't left some additional code if we have, for example, a smaller file in our firmware that was before on that partition. And in the other case, we just can use unzip without that zero part, and that case is for ext4 partitions, for example. And also you can see that we can use unzip here, so it's checked here actually. And if we can't use unzip, we will use just 7-zip, and 7-zip is packed also inside those zip files, so it's the other approach here if we can't use unzip. So I think it's simple, and we can also try to find that unzip. And you can see here how we test it, if we can use unzip command, and if it works correctly. Here is the explanation and how we test it, and then we are just putting true or false in unzip. and if it works, it's the part here that we use, and if not, we are also prepared with 7-zip binary also. So as you can see, that is how we can prepare those scripts modified. I'm of course aware that you will have to spend some time to modify it. It will be easier to modify it for previous Samsung devices because it should work like that or with really slight changes, and for other devices it will require some more work. But I think it will be simpler that just start from the scratch, and I think you will find that approach useful to you. So once again, remember to subscribe my channel if you haven't already done that. Also check my previous videos. Thank you for watching. Bye.